Alright guys, time to get started. So I'm Matthew. If you don't know me, I'm Matthew Rathbone. I run the Meetup group with Pit Fagan, who's over there, who's going to wave. So thanks everyone for coming. A lot of you have been here before. It's great to see everybody again. A lot of you are new. Welcome. A couple of quick things before we get started. So beer and pizza and soda tonight is sponsored by Cloudera. So they're in town, they're in the local area, so big thanks to them. We go to the Silver Dollar right after this and get a round of drinks. So that's also on them, hence the drink sponsorship. Just wanted to let you know about those guys. Meetup next month, October 28th. It's on Apache Drill. It's going to be presented by Matt R. So it's going to be in this room, October 28th. Put it in your calendars. We have Meetup scheduled all the way until February. I think the only one we're not doing is December due to the holidays. So those details will be announced as soon as we have all the abstracts. So he's already kind of been talking, but I want to introduce Max. Max gave a previous talk at Big Data Meetup. It was really popular, so we had him back, and hopefully you guys can learn to be graph database pros. So I'll just turn it over to Max and let him do his thing.
All right, thank you. All right. So I guess I'll start with a happy little presentation. So a couple months ago, I asked on Kickstarter for some funding in order to produce a video course on my spare time that I rarely get about Neo4J and how to write Neo4J services that are successful. Because there's many different ways to talk to a database, and this is what I found to be the easiest, cleanest solution, and the one that actually performs well enough. So I created this high-performance Neo4J video course. I sent all of you the links. They should be on the Meetup. But if you don't have it, I'll be at the end of this presentation as well. Now, I was going to try to go through that, but realizing we only have about 2 hours, is just not going to happen. So instead, what we're going to do is we're going to go with the high-performance Neo4j compressed edition course. We're going to try to give that a shot. So this is Max De Marzi. That's me, my bald head up there. Feel free to grab me and contact me and email me. I get emails from people all day long. That is my job, to respond to email. You can also grab me on Skype at Max De Marzi. Just call me if you have a graph database emergency, whatever that could be. I blog about Neo4j at maxdemarzi.com. There's like 61 blog posts for the last 2.5 years on things you can do. 99% of the time, there's a GitHub link at the bottom telling you where the source code is for everything. Everything is open source and MIT licensed. Feel free to grab whatever you want and go crazy. And that's my GitHub account that has, that plus a few other random stuff that I haven't gotten a chance to blog about yet. There's like 50 draft posts that I'm just too lazy to get through. But anyway, course outline for today. We're going to look at Neo4j server and how to turn it into a Neo4j service. Right? How many of you still write monolithic apps that have everything included in just one big app? Nobody raises their hand? No one, everyone's ashamed to admit it, right? So I'm sure you were a junior at some point, right? And then you created these crazy Rails app that had everything in there. And then you realized this was a horrible idea, and you started breaking it up into services, right? Hopefully you haven't gone onto the bandwagon of microservices where you're writing like 3 lines of code and deploying that. But we're going to look into services with Neo4j. We'll do a little hello world just to make sure everything's wired together and wired up and you can get the server talking to you. We'll look at just quick warm-ups to show you how to grab everything in the database. We'll look at friends, so giving a user how to get that user's friends, and then we'll do a little bit of recommendation algorithm. So given what we know about a user and their friends, recommend other people they may be friends with. Really simple. Hopefully we can get through it in 2 hours. We'll see. So Neo4j services. Ignore that chapter 3 there. That's a copy and paste from the other place. There's many different options in how to connect to Neo4j, right? There's the client drivers, and there's a client driver for just about every language and framework out there. People have written tons of these. You can write one in about a weekend if you feel so inclined. The other option is to go full Java and embed Neo4j into your project. Neo4j started its life as an actual, the 4j comes from it being a library for Java. It's a horrible name. We're stuck with it. It's not going to change now. But if you want to go that route and you're a Java shop, then that's perfectly fine for you. And then the third way, which is my preferred way, being a Ruby developer, is to extend Neo4j, which means you have to hold your nose for a little bit, write a little Java code, and then you're flying. And the idea is you're going to extend the REST API that Neo4j provides with the stuff that's important to you. right, your own API on top of Neo4j. So it's kind of like if you were able to go to MySQL or Postgres and be able to add extra endpoints for you directly without having to write your own part of the language or anything like that, or extend the language of SQL. You just say this endpoint is going to produce this response. So we're going to try that. So client drivers, though, is the fastest way to get started. So if you're just starting out with Neo4j as your first experience, don't listen to me. Just connect to it with your favorite language, your favorite framework, and start playing with it. Get through that first initial phase. It's not an easy learning curve in the beginning, but after a few days or so, you'll get the hang of it, I guarantee you. You're limited, though, by the REST API. You can only do what's there, plus Cypher. It's also the slowest speed because you're sending in commands, you're getting back JSON, which then you're turning into an object, and then you're probably spitting back out to JSON again through your language of choice. But it's easy to deploy. You just start up Neo4j and start talking to it from whatever language you got. The second way I was mentioning is embedding Neo4j. Slowest way to get started because you have to figure out everything. You have to figure out how you're going to deploy this. Where is this going to go? Set up your Tomcat and all that mess. It's very, very painful. But you have complete control. Right? You have the full ecosystem of Java and JVM ready to go. Those are going to give you the fastest speed because you can decide not to go HTTP. If you're building a service that's underneath the covers, it's not going to be talking to a human being over the web. You can choose something else and have a proper socket back and forth. It's also the hardest to deploy because, once again, you have to figure everything out. Third option is my favorite option. It's basically standing Neo4j, right? In Java, in Clojure, in JRuby, in whatever your favorite JVM language is, you can add it to Neo4j and talk to it through there. You're limited to HTTP, though, so you're not going to be able to do anything like WebSockets or anything too crazy. But it does give you the hard work being done in Java and connecting to it in your favorite language still, but just creating a client driver for it. And then it's really easy to deploy. You deploy it with Neo4j, so you don't have to worry about how to set it up. All right, so we're going to go with extending Neo4j. And there's a few blog posts regarding how to extend Neo4j also, so this shouldn't be the only time you'll ever see or hear about this stuff. So this is what I want you to do. This is going to be a hands-on class, so hopefully you brought a laptop. If you didn't bring a laptop, then hopefully you brought a friend with a laptop. If not, make a friend with a laptop. I want you to clone this project. This is on GitHub, and it's Neo High Performance Compressed Edition. And then we're going to follow steps 1 through 12 on the README file. These are going to set up Neo4j. I'm going to have you download it. I'm going to have you change the config file. We're going to go through it together, but I just want to give you a minute to type in that address or start cloning it directly here. You can hit if you don't have Git installed, you can also just hit download on the bottom right, and it'll start downloading for you. So let me just switch over to that. Don't worry, I'll leave the URL up in a second. This is github.com/Max De Marzi/NeoHPCE. There's the URL as well. Okay, and either clone it or hit the magic download zip button on the right. And then we're going to go through all the steps. So I'll give you a minute to get to that site, and then we'll start together. So, for example, let's give me a bash shell. And let me zoom in so you can actually see what I'm doing. All right. So git clone and that project. Everyone get through that first part? Let me know if anyone's having issues, all right? Or grab a neighbor. You want to just git clone it, or you can just download it, or you can CD, or you can, I don't know what else you can do. I think that's it. Clone or download it to you. Then I want you to CD into that folder, obviously. And from there, we're going to follow the rest of the steps in the README. So if I bring up the README, you'll see a few steps on here that says download Neo4j. If you already have it downloaded, that's perfectly fine. If you don't have it downloaded, then this is the time to do it now. So we're going to grab the first command here, curl it, and paste it in. What's nice is that the library here has really, really fast Wi-Fi. And you can see it's flying through this, so it won't take more than a few seconds to get it done. So we're halfway done already. 80%. Almost there, and 100% done. All right, so we downloaded Neo4j. Now, obviously, I'm cheating because I know that the URL directory. Otherwise, you'd go to the website, you go to neo4j.com, hit download. They would ask you for your email address, and then you get spammed, but you would have Neo. Same idea. After I download it, I want to go ahead and compress it. So just follow along with the next command. So that was a tar gzip uncompress. That made a big mess here and created this Neo4j community 213 directory. What I want to do next is go ahead and rename it to Neo4j. This is so everyone's following along in the same way. How are you guys doing? Are you guys in the same spot as I am? Am I going too fast? Too slow? Don't have? Okay, good. So we changed that up. Now I want you to try building it. So Maven clean package. Now, who doesn't have Maven installed? Inside that directory, yes. If you don't have Maven installed, you're going to have a few minutes to go ahead and download and install it. It's basically Maven clean package. I am not a Java developer, so this is as much Maven as I know. Really, it's crazy.
You could use Homebrew if you don't have it.
So brew install Maven? Okay, brew install Maven if you're on a Mac. If not on a Mac, then pray for you. It's something to figure out.
Can you show what's in that directory?
Sure. So right now we have license file or README file. We have downloaded Neo4j, and we've zipped it up and moved it to its own Neo4j directory.
So where did you get the POM XML? Because I don't have that one.
Oh, when I did the cloning. So when I ran this git clone command.
Oh, okay. So you want us to download within the git.
Yep. So either git clone it, or if you go to the directory, you can just go to the right, there's a download zip button. You can do that as well. And then unzip it, obviously, and then go into that directory. So I'll let you catch up. And in here, what you'll see is, you'll see a source. To get ignored, license, README. So the README is what we're going to be working through. There's the 12 steps about setting it all up. When we get to step 12, we're going to stop, and we're going to actually look at some Java code, and then we're going to go through it together. So you get the hang of writing and talking to the database directly. What I've done is I've created a bunch of tests that I've ignored. We're going to remove the ignores, and you're actually going to write the code to make the test pass. And once the test pass, you're going to build the jar file, plug it into Neo4j, start it up, or restart it rather, and you'll be able to ask new commands of it based on its new REST API that you just created and get information back. So once again, download it, download Neo4j, follow the instructions. If you're already ahead, if you're fast, then go through step 12. If not, then just wait for me and we'll do it together. Okay? So I built the extension. And what this thing did, it created a target directory, and inside that target directory, it created this little jar file. Neo4j is extremely extensible, right? First of all, it's open source, so if you don't like the way something is done, you can just go to the actual code, change something, and go on from there. But it also gives you the ability to do kernel extensions, plugins, and then unmanaged extensions. So we're going to be doing the easiest one of the three, which is the unmanaged extension. When you go to the documentation for unmanaged, Neo4j does something kind of evil. They make it sound scary. So if I go to search, look for unmanaged, it says, warning, you may kill yourself. It's not true. It's going to be fine. There's nothing dangerous about this. This is the way I build Neo4j services, and it's perfectly fine. No paper cuts yet. But so ignore the big warning sign, really. And he actually goes through and explains how to do it as well. But we're going to do it together here, so it's going to be better. All right, so how many of you have this jar file built? Show of hands. All right, that's like half of you. Is that true? Are you guys having issues? Are you guys okay? Some of you guys have been working for 8 hours and don't feel like following along. That's cool too. No worries.
I feel like it took a long time to build on my machine. Like I started it before we got there.
Okay.
So I'm new to this. Is the POM file specific to the fact that you're running on a Mac?
Yeah.
Okay.
Yep.
I guess I'm getting some, let me see what it is. It's some complaint that the POM file may not be for this particular project. But I'm in Linux, so I wasn't sure if it was
Interesting. It does want you to have Java 7 installed. So if you're in Java 6, you may be having issues. And that's ancient. You shouldn't be on Java 6. you're in Java 8, it should still work.
Can you give us a quick link on Java 7?
Oh,
For the Mac.
how do you install Java 7 for the Mac? Anybody know? I think you can,
Well, like, magnets. It's your pro. No.
Yeah, you have to download it from Oracle.
Yeah.
yeah, so just go, do what Ruby programmers do. They ask the all-knowing, all-powerful Google, how do I do this? And it tells you. It knows. There, look, download the latest Java. See, it knows what to do. So, worst case, you can, like I said, you can buddy up with somebody while we go through it. You have plenty of time. No worries. So we built this extension. We created this jar file. The jar file is going to be the container that has all our code. And what we're going to do is we are going to follow the instructions. And it says, I want you to copy this jar file into Neo4j plugins. Oh, I'm in Target, that's why. I was like, really? Did I mess up? There it goes. So what I did here is I took this jar file we created, and I added it to Neo4j plugins. Neo4j plugins is where you're going to put in your kernel extensions, your RMagic extensions, and your plugins as well. It's just called plugins to make life easier. We're basically telling it, when you load up Neo4j, when you start up Neo4j, take a look at this code over here, and we're going to use it as part of our project. Okay? And then it tells us that we need to configure it to use it. So there's a little line you have to add to the server properties file. So in Neo4j conf, Neo4j server properties, scroll down about halfway. It tells you about, you want to add an extension, this is how you do it. And we're basically going to paste one in there. The name of the project is com.hpce, and we're going to tell it that it's going to use the endpoint version 1. Is that hard to read? Yes, it is. Let me zoom in a little bit.
Does it have to be that precise location in the file?
No, it could be anywhere. It's just a text file. It doesn't really care. As long as we're telling it that we're going to use this third-party class, that's what it's called, and that's the endpoint is going to hang off of. So v1 for our API versioning. And we'll save this file. And the reason I'm making you do this is so that you do it once, you never have to do it again. And then we'll start Neo4j. And you'll get this happy little waiting for it to start. It'll complain about not having set up something. What did I? Oh, not changing user. Doesn't matter. I'm running it as local. And it tells you localhost 7474 is ready. And you can copy that into a browser. We're going to use Firefox for this. Hit the magic button, and we should get our Neo4j instance. So I'll give you guys a minute to get here. Once again, go ahead and add this line to your Neo4j conf server file, and then start Neo4j. And to make sure that everything is working, we're going to follow step 9 here. We're going to run that. We're going to tap that up there. Basically, this is saying we extended Neo4j, we added a new endpoint to the server. v1 service hello world tells us hello world. And obviously, right now it looks like magic because I haven't shown you how we got here, but I will do that next.
Hey, Matt.
Yes?
When I start Neo4j, I get a warning that Max or OpenFile allowed minimum of 40,000 records.
Yeah, usually as part of Neo4j, like setup documentation, it tells you you're supposed to do a few things to make life better for yourself. So under operations, configuration, performance, there's all these things you have to do, like set up the number of files, max open files. That's somewhere near the bottom, I think. It's set up. The U limit should be 40,000 or more. That's the number of open files. We use Lucene for indexing, and sometimes Lucene opens up tons and tons of files. So that's one of the reasons that can show up. I mean, 40,000 is plenty. I thought we had one customer that had to go up to 60 just to make sure it all worked, but that's about it. 40 should do it. There's a few things you're supposed to do as well, if you read the manual, which nobody does, like setting up the your dirty background ratio. So Neo4j will control when it writes or when it flushes a file to disk versus the OS doing it. This is kind of important if you have lots of writes. If you're on a virtual machine as well, it's kind of important because otherwise the VM will fight for it, the OS will fight for it, and Neo will fight for it. And you don't want 3 things fighting for it when you can just have 2. So always read the manual. It's good stuff in there. if you go into production for your laptop, it doesn't really matter. You're okay. Just ignore the warnings. Nobody ever pays attention to the warnings anyway. All right, I don't want you to get to this point where you have the ability to issue a get command and get an answer back and get a hello world. All right, so I'll give you a minute or 2 or 10 to get there. Once you get there, raise a hand. Let me know that you got there. See you guys? Okay, good. So we're getting there. So what kind of magic, what kind of sorcery did we do to get there? I'm going to close this. And we're going to close this as well. And close everything. And man, I have too many of these things open. Okay, so I'm a Ruby developer, and someone told me IntelliJ was the right IDE to use. Some people who are on Eclipse probably think I'm an idiot. It doesn't matter. This is the one that I've learned to use. And I'm going to open a project here. In the directory I had you download, there's a POM file, which you're going to open with IntelliJ or Eclipse or whatever your favorite IDE is. And this is going to have our code, and this is what's creating that endpoint hello world that we just saw. So we're going to walk through it together. And let me not get ahead of my presentation. So this is where I'm at. And get v1 service hello world. Okay. So the file I want you to look at is called Neo4J service. Can you guys read that? Is that okay? Too small? How do we zoom in on this? What do you think? Is it doable? You want me to go smaller? Displays. Let's go here. No, it's not. That made it worse. Alright, we'll stick with where we are. So we're limited by the resolution on the thing. If somebody knows IntelliJ knows how to zoom in, I'll be glad to know it. If not, no worries. Okay, so we have a class called Neo4J service. You can call it whatever you want. The only trick, though, is that it's in the package com.hpc, which we configured for where this jar file is going to live. And ignore the crazy stuff I don't talk about. Just look at this part right here. So we configured this in Neo4j. We told it that it was going to live and sit under a v1 right here. We told it it was going to sit under v1. And then Neo4j service, we told it that it was going to live under this path called service, and then inside of that is a path called hello world. And that's how we get to that hello world function that is being called. This is JAX-RS. So if you know Java and you know JAX-RS, this all makes sense to you. If you're not a Java developer or you don't know JAX-RS, you're like, what is Max doing? It was news to me as well, but it's okay. It just means your code here is going to get plugged in directly to the REST API, which is pretty nice. So this service hello world function returns a string, and all it does is say return hello world. Okay? And with just, forget the rest of the code on here, if you just have that and you attach that, you build a jar file, you add it to Neo4j, you configure it and you restart it, you have a hello world endpoint. You've extended Neo4j to your world, you can do whatever you want with it from then on. So, how have we gotten here? I want you to go ahead and change this to be something else, like hello Max, and then run your tests. So there's a bunch of tests over here. You can say run all tests, and it should fail, I think. Right. Say complaint, and it says that this should respond to hello world, did not. Instead, we got hello Max. So you know the thing is working in some sense. We have a bunch of tests over here that have been ignored. We're going to go over those a little bit later. But if we change this back to be hello world, then we have a passing test that we can move forward. Give it a second. All right, and now it's happy. So this is the setup. This is what you need to do to get started with this API. Now, I have a few methods that we're going to go over that I've created for you. We're going to warm up the database. This is an endpoint that's kind of strange, but I like having it to every single project. what it's going to do is going to take everything in the database is on disk, and it's going to load it up into memory. So when you're doing performance tests, or when you're doing, ultimately when you're running in production, you always want to have all of your Neo4j database in memory. You're going to have a much easier time. If you do not have everything in memory, and you have to go to disk, it's going to suck. I mean, the whole point of this, and like one of the new things that are surging in the NoSQL space is all these in-memory databases. They don't even actually write to disk at all. What they've realized is if you have a cluster of machines and you have very high-speed networks between them, it's actually faster for you to talk over the network to the next machine than to write to disk. Right? And the networks are getting faster and faster, and your servers can have more NICs as well. And this is how like the Beowulf clusters and some of those guys work. They don't ever write to disk. They all talk to each other through the network. And if you have many of them, then that's good enough, right? If the majority of the servers in your cluster say, yes, we got this right, you can claim that you have it saved somewhere. And that's good enough. And then you can obviously back up once a minute to disk or do backup to S3 or something else like that. But always keep everything in memory. You'll have a much easier time. So warm up. Let's look at this method. That's the one underneath that. So it's another string. And in this case, we're telling it that we're going to pass the context. That's the graph database service, which is always strange to me. But what's happening is this URL endpoint is getting this database passed into it. And the database comes in from Neo4j. You don't have to worry about how it got created. You don't have to worry about what the configuration is, what the setup is. It's just going to be pulled in directly from Neo4j. And then whenever you talk to Neo4j in version 2.0 and greater, you have to start a transaction. Neo4j, and actually all the graph databases, decided to go a different route than the majority of NoSQL. A lot of NoSQL said, forget ACID, we're going to go base. We're going to be eventually consistent. We're not going to worry about having proper transactional support like you're used to in SQL. The graph databases said, that's crazy for us. It's not going to work. It's going to make a mess. Because if we have dangling relationships, it's going to break everything. So we decided not to. Instead, we have full ACID support. We can start transaction and transaction commit it as we go along. So in this transaction, we're going to say, grab all the nodes in the database. This is a global graph operation, something you rarely do, but for warm-up, it makes sense. Take all the nodes in the database and get their properties. And then get all the relationships of these nodes and get all the relationship properties as well, and the start node of where it came from. And that's the warm-up, and it just returns a string saying warmed up and ready to go. So the exercise of doing this is going to go through all your files, bring them up into memory, all your properties, bring them up into memory. And if you have enough memory, enough cache, everything will be up and ready to go. So we can run this in our browser here. Say warm up. And I'll just say warm up and ready to go. The database is empty. There's nothing in here. So obviously it takes no time at all. If you have a million nodes or so, it'll take a few seconds. If you have 15 million nodes, you're looking at maybe 5 minutes. Once you get to like a billion or so, it could take a little while. It could take 20 minutes for it to warm up, depending on how fast your disks are and your servers overall.
Why do you have to get the start node?
Click on the end node. I just need to tell the relationship to grab part of its record. And it's a good point, and it doesn't make sense until I explain something else. So let me jump into that real quick. So we're taking a second here. So this is good because I actually need to show. So I'll bring it up. We'll just pretend that I got there magically. So bring it up. Okay. There's a blog post from August 2012 called Neo4j Internals. And skip the presentation, go down to skip this horrible picture, skip down to this. And let me zoom a little bit out. Okay. This is the secret sauce of Neo4j. This is the secret sauce of graph databases in general. Right? There is no magic in computer science, unfortunately. You only get two things. You got data structures and you get algorithms. Right? So the way graph databases work, the way Neo4j works, it's by this data structure. This is what it's in the cache. What you're looking at here is two arrays, one array of nodes, one array of relationships. And this node here has an ID, and the relationship has an ID, and these are assigned by the database automatically. And they can, ID 1 for node and ID 1 for relationship obviously are different. That's perfectly fine. But you only get one ID for the whole node space and one ID for the whole relationship space. Now, off of each node, you have types. These are the relationship types that are connected to this node. So your type 1 could be friends, type 2 could be enemies, type 3 could be locations, whatever that may be, or your likes, for example. Off of each type, there's 2 lists, an incoming list and an outgoing list. Every single relationship in Neo4j needs to have a type and it needs to have a direction. You don't have to treat them like if they had a type and direction. You can just say, are these 2 nodes connected, period. And that's perfectly valid. But underneath, in storage, in the cache, throughout the whole system, they're going to have a type and they're going to have a direction. That's where this in and out comes from. Now, R1, R2, Rn that you see up here, they're pointers. They're pointers to the relationship array. And the relationship array, because it has an ID, and it has a start node and it has an end node, and these are pointers back to the node array. Okay, so these guys point here, these guys point back. And there's a type at the end. This type corresponds to the type where it came from. So if this is your friends, that's going to be friends as well. And then nodes and relationships both have key value pairs. These are the properties of the node and the properties of a relationship. So this will be, your username would be here, your name would be there, your email address, and so on. Right? If you have a relationship, it's a friendship relationship, this could be the start or where you met or some other information about that relationship. So what happens here? We start on node 1, let's say that's the user that's currently logged on. We ask for all its friends. It's going to go up to type 1. It's going to go to the outgoing relationship into these relationship pointers. So I'll point here. It said I came from node 1. The end node is going to be my actual friends. That's going to be node 2, node 3, node 4. And I'm going to get their usernames by looking at the key value pair for username. And what we're doing is we're spinning. We're spinning through this data structure in memory. Right? And you can do anywhere between 1 million and 4 million traversals per second per core on newer hardware. So if you have the high-end stuff, you're looking at 4 million. Cheap stuff, you're looking at 1 per second per core. So that's quite a bit still. Now, what are the trade-offs, right? Or what's different about this thing? What happened to our joins? What happened to our data? Something we forget. We were used to relational for so long, and people look at how we scaled relational databases into NoSQL by getting rid of the joins. All the joins kind of disappeared, right? You have object databases where the object is composed of all the things that encompass it. So a user may have his address attached to it, or may have other properties that would normally be in a separate table attached to it. And doing joins in like a MongoDB is kind of hard to do. In the column stores, they attach things up and down the columns instead, and doing joins is very hard to do there as well. With graph databases, we went the other way, completely the opposite way. That's why we're like the redhead stepchild of NoSQL. The joins were materialized, right? So this in and out list that you see here, those are your joins, right? Everything in a graph is pre-joined. You never have to do a lookup. Typically, when you do a join in a SQL database, you have this log you have to look up, and you have to say, okay, I'm looking for foreign key number 345. Find it in the log. What does that point to? And then go there. That points to another foreign key, and then you go on from there to get the actual table that you care about. In the graph, none of that stuff exists. There's no lookups. The joins are set up for you by pointers in this list. And you can just go straight to the relationship, grab it, and then go back and grab it there, and you're just spinning through pointers. Now, the trade-off is, what's the next node? We don't know what it is. It could be a user, it could be a location, it could be a thing. We don't know what it is. So if you're asking the question, what is the average height of all my users, you're going to have a bad time because you don't know what's next, right? So you're going to have to kind of skip around until you find the next user and then go down from there. Whereas within a relational database, they're all together in that one table. So you can just go to the next record and count it and go to the row that you care about and continue on. If you're in a column database, you don't even go to the next record, you go straight on the column and you get your answer. So if you're looking for things like what's the average height of all my users, way faster in a column database. Not so bad in a relational database, horribly bad in a graph database. But if you're looking for things like how are these things connected, really good in a graph database, crappy everywhere else. Does that make sense? All right, good. Let's go back to this. So the reason we get this start node, which was the original question, is to be able to tell it at the relationship level to pull this set of records. Get the start, get the end, get the type. It's all going to come from this together by forcing it to grab one of them. That's what I'm doing there. It's a little bit of a cheat because you have to know the internals to understand that that's what the warm-up is doing. But we get warm-up out of the way, then we go to the next method. So graph databases are schema-less. They become schema-optional. So you are given complete control. You don't have tables. You don't have this things to hang on to. Instead, you have these nodes floating around in space. Right? And by complete control means you can have a node that's a user, and you have some properties about a user, and that's perfectly fine. You have another node that's also a user that has completely different properties, and that's perfectly fine. That's okay, and they can be friends with each other. You have complete control. We don't tell you that these things only have to have these properties, or that these nodes can only be connected in a certain way. It's up to you. So you have to be careful, because all that power means that when you're coding something up, if you have a typo anywhere, you're going to make a mess of things. Right? The database is not going to stop you and say, whoa, that's not the right table. It'll let you do whatever you want. So be careful with that. So in 2.0, we decided we're going to hold your hand a little bit better, and we're going to add optional schema. So this migrate method here, what it's doing in SQL, in our database rather, it's adding a few constraints. It's saying we're going to have these nodes that are going to be of user type. They're going to be type user. We're creating a label for them in a way of saying, like, we're going to have like a users table. And they're going to have a username, and that username is going to be unique. So we're creating this constraint for a database, which is very new. It's kind of weird to do that in a graph database, but for actually building applications, it makes sense. You want to have things that are unique. There's going to be social security numbers. There's going to be your employee ID numbers. There's going to be your user, your emails. These things are going to be unique, and they make sense that way.
Is that the only constraint?
That is the only constraint we currently have. Yes, indeed. So there's plans for things like these things can only be connected this way, or this property type can only be a string, or it can only be a number, or it can only be an array. All that is coming, but it's not critical. The uniqueness, though, it kind of was, so we decided to throw that in there. And the second part, what it's doing, it's saying start another transaction again, and wait for the indexes to come online. So when you create this constraint in the background, it's going to create an index for you automatically. And it'll take a minute or two to come online. I'm asking to wait for a day. Obviously, it won't take that long, especially if there's no data. But it's handled in the back for you, so you don't have to worry about updating indexes manually. In the olden days, 1.9, you created these indexes, and then you manually changed the value of the index every time. So if you updated a record and you didn't go back and change it, it would be pointing to the wrong thing, which was horrible, right? It was a bad idea. But that's how we lived with it for such a long time. Remember, Neo4j is at version 2. Your Oracle system is at version 11 or 10, depending on how back you are. SQL Server is at version 12 or something like that. I mean, it's going to be a while before we get there. We don't have 30 years of hundreds and hundreds of thousands of man hours or millions of man hours behind us. So, but at least we have proper indexes that take care of themselves with version 2. So that's what this stuff is all about. So we'll run the migrate command, and this will create the label user, and it'll create the index that we're going to be playing with. And it'll tell you it's migrated. And if you try to run it again, it should complain. It should say it's already migrated. Haha, you can't do it twice. That's what that crazy if statement that you saw up here was. If it already has a constraint, then just skip it and tell me it's already migrated. Obviously, in this case, it doesn't really matter. But if you're building a real system and you have migrations, you don't want to run the same migration version multiple times. You'll have, only this one can run and then that one can run. You'll have checks for that. So I just want to show you what that looks like. Let me close that off. And close these guys off as well. Alright, now we get to the fun part. So, get user. And I don't have the code written. Instead, I'm going to ask you to write the code. I'm going to show you how this works. We're going to write it together as we go along. The first API endpoint that I care about is being able to get a single user out of the service. We're going to skip this part first. We'll go back to it. That is, we're going to get the version 1 service user and some username. Are we going to expect to get some value back, the properties that they have? Okay? So how do we do this in the graph? If you think about in a relational world, how would you do it, right? You'd get the username, the variable coming in, and you'd say, go find this user in my index somewhere, bring that back to me, and then get the properties for that record and show them back out in JSON. And that's exactly what we do in the graph. The best way to learn Neo4j, not the right one. Ugh, really? Hold on. API. They changed the freaking URL on me. Okay, let's see if it's back somewhere. Java docs. Okay, good. That's still there somehow. So before you simply just go to docs on neo4j.org and it would just magically take you there. Now you have to not do that. Oh, it does still work. Okay, never mind. No, it doesn't. This is what works. So go to the bottom of this page, and you see the Java docs. Kind of hidden. We don't want people using this stuff. No, it's not true. We do want you using this stuff. I want you using it because it'll make my life easier. If you use the Java stuff, your code will be faster, your access to the database will be faster, and then you'll have less problems. The reason for it is this. How many of you write handcrafted SQL in your code right now? A few of you, right? And you're not ashamed to admit it. All right. How many of you write ORMs or use ORMs to connect to the database? Right, it's the great majority of people. All right, we have abstracted that away from you. And in Neo, we say, wait a minute. No, we want you to use the SQL replacement called Cypher to talk to the database. And we do want everyone to learn Cypher. But Cypher is what your business analysts, what your data scientists, what those kind of people learn and use to create reports and build ad hoc queries and investigate the data. Right? As developers, you can go that route, or you can get lower level. And lower level means talking to the database directly through Java without having that barrier in between you and the language. Now, it's not that I'm against Cypher. It's just that it's not there yet. You know, the language is only about 18 months old. You don't have, you can't do everything the database can do yet. And I don't know. I just prefer going to the database directly. I think you get a lot more speed, a lot more performance that way. Now, that's going to change. One of the big things we're working on this year is to make Cypher only be twice as slow as the Java API. Right now, it's sometimes up to 10 to thousands of times slower, depending on what you're trying to do. Remember, once again, your database vendors have had 30 years of query plan optimizations. We've had like 6 months. So it'll be a while before we get there. But you can skip it. You can go straight to the API. And this documentation, it's a little bit of, wow, I can't believe I have to learn all this. No, you don't. We only have to learn a few major things, and the rest is there just for browsing purposes. But I'll show you how it all works. So I want to get a user from the database, and I already told you, the first thing you always have to do is start a transaction. Right? Then we're going to let the magic power of Java IDE tell us what's going on. So we can say something like database. I want to find the node. And you go, all right, that's not it, that's not it, that's not it. And then find nodes by label and property. All right, that's probably going to be it. It's telling you to use a label. So we created, we're going to have these users, and they're going to be labeled by this user command. And I've cheated already, and I've created an enum with labels already on it. But you can type labels dot, and it tells you there's a user label in there. So let me go back here and tell you what this is about. Here's just a happy little enum that says I implement label, and we have users. There's also another one called relationship types that implements relationship type and has friends in it. So these are going to be the two things we're going to use in a system. You can also dynamically create them as you go along, but you're better off having types and labels separate in one place so when you don't have typos or anything crazy like that. Alright, besides the user, it was asking us to use what value or what key value pair are you going to find them at. So we're going to have usernames. That's going to be the key that we care about. And the value is going to come in, it's going to be called username as well, it's going to come in from this path parameter. Right, this little squiggly username up here, if you know JaxRS, you know that's a path parameter. It's going to get mapped into that, and we're going to use it over here. Okay? Okay. Now, if we just find it, it's going to go ahead and find it, but that's not what we want. What we want to do is return the actual node that that user represents. So we can say node user is going to be equal to that, and it's complaining. What is it complaining about? Cast to db.node. What? Right, why? Because that's not really going to get a node. You know what that's going to come back with? It's going to come back with an iterator. Because it doesn't know that you only have a single node with that username. So until we have this iterator thing. So we have to get the iterator, then we have to get next, and something like that. And it's pretty horrific, and that looks ugly. So what the Neo4J guys realize is that we're going to do something a little bit easier. We're going to help you out. So they have a helper class. Iterator util. That's what it's called. And it says like get, no, somewhere in here. First or null, I think is what we want. First or null. Right. And then we take this thing up here and stick it in there. And then we semicolon out. Alright, yeah, how's that for horrible, right? I didn't particularly like this change, but find nodes by label and property. It's Java for you. Alright, it tells you exactly what you're doing. Alright, so we're going to go out into the graph database. We're going to say find this user that hopefully exists by this label user that has the username property and has username value. And then we're going to say, okay, if the user exists, so what is that? It's not equal to no. No. Alright, then we're going to do something with it. So what are we going to do with it? Well, we have this result up here, which is a hash map. That's what we're going to respond ultimately back and convert that to JSON. So we're going to fill that result with something. So we're going to just say, what? Results that add, is it put, there we go. Username. And we're going to get a key for the user. So we're going to get the user dot properties. So we're going to get property, there it is, and username. Alright, that seems to work. So without IntelliJ, I would have to dig through the documentation and try to figure out what the heck is going on. But what I basically am saying is find this user in the graph, then get its property. The property is going to be called username. Get that value and stick it in to the result hash with this username as the key value pair. And then we're going to return the results back. Hopefully that works. I don't know. We're going to our unit tests, get user, and we're going to remove the ignore. And then we're going to try running it and see what happens. See if I messed up or not. Alright, so there's our get user, and should get user is passing, so that's okay. And it's expecting a hash map of username with a value of A, and that's whatever user gets created. I'll go into the unit test a little bit later. I just want to show you what that looks like. What do you guys think? Oh, it smells, right? I don't particularly like it. Having to do this. This kills me. This kills me. Really? You couldn't give me a shortcut like get user or I don't know, something, I don't know. So if you have any, spare cycles, and if you're a Java developer and you want to change your API, I would welcome a pull request that figures it out. But for now, we're stuck with this thing. But this is how we get a node out of the database. And we check to see if it's null or not and get a property out of it. And we pass it back and we get some JSON out of it. So what are we going to do next is we're going to try this out. So in our project, we built this thing a little while ago. We typed Maven clean package to build it. So we're going to do that again. And we'll give it a second or three here. We'll run a little test. We know it just passed, so it should pass again. Alright, no problem. Then I'm going to copy the new jar into the Neo4J plugins again. And then instead of starting it, I'm going to restart it. And then what this is going to do is going to reload the new jar file that we just added with this new code that's going to get a user, and it's going to be ready to go. So I can go to Firefox, and I can say service user max1 here, hit enter, and I get nothing back. But at least it didn't give me an error. So at least it's trying to get me something. Because then max1 has no properties. Why? Because we actually haven't created any users. We don't have any relations, we don't have any data. Now, in the presentation, or in the instructions, here's a way to make some users. So you can go ahead and copy and paste this code. I'm going to go through and explain what's happening here. We are going to create a variation of 10 users with a bunch of numbers behind them. So this is Jennifer, Michelle, Tanya, Julia, and so on. And for each one of these, we are going to create a user times, and we're going to repeat them, adding a number to the end of them 100,000 times. So let me show you what that looks like. I'll grab it not from the presentation, but from this code up here. Copy and paste. Magic. Play. These will take a while. We're creating 100,000 users. It'll take a few seconds here. You'll see how fast your systems are compared to mine. Dun-dun-dun. Executing query, going on forever. Usually this is faster than this. I didn't type one have an extra 0 in there anywhere, did I? Demo gods are getting me. Really? Oh! I made a crucial mistake. That's what happened. Now, you know what a mistake is? I created the schema first. So now it's doing a lookup every single time to see if it's a valid user or not. And if you're a database guy, what do you do when you have to import loads of data? You drop the indexes, right? And then you build them afterwards. So now what are we going to do? Oh my goodness. We're going to have to fix it somehow. So this is how you debug Neo4J. You're going to try to stop it. Yes. Is there a kill query command? No, there isn't. Is there one coming out in the next version? Yes, there is. For this exact reason, because it's really stupid for us to have to go and say stop the database like this. And if it doesn't even want to stop, you know what you do? Kill it. 5, 6, 7, 5, 2. Die a horrible death. Alright, now I should be dead. Let's see. Yeah, I know an error. Of course I know an error. Okay, now you're dead. Alright, so let's rewind. Let's fix this. We can do this.
Can you elaborate a little bit more on why that is taking so long?
I will.
Even if you have constraints in a regular SQL database, 100,000 inserts won't take that long.
Yes, 100,000 inserts shouldn't take that long. 100,000 inserts in version 2.13, which is the one I'm currently using, in one transaction, take forever. Why? There's a bug in 2.13 where if you try to, every time you add an extra lookup, it does them like over and over again. So it's doing 1, and then it's doing 2, and then it's doing 3 lookups instead of doing 1, 1, 1, 1, 1. Believe me, it's retarded. That was fixed in 2.14, but we're using 2.13 in this version. 2.14 has other bugs. Don't want to use that one either. Here's the thing, right? Neo4j, you always want to be about a version behind. So if you're on 2.04, you're going to have a good time. You're going to be in production, you're going to be happy, everything's going to be okay. If you're on latest, you're going to pull your hair out like I did. It's not a good time. You want to have the dating sites, they run the latest, they find all the bugs, they let us know, and then we fix them. So don't be, unless you're a dating site and you don't care if someone loses their love of their life, then don't use latest. The people doing real stuff, don't use latest. Stay a step behind. All right, so I killed the database. That's horrible. Then I'm going to restart Neo4j. So I killed the graph.db directory, and when I restart it, it's going to create an empty one. My constraints are gone. Everything's gone. But my plugin is still there. My configuration is still there. So I should be able to reload here, and I should be able to go back and paste that in here and hit the magic run button. And hopefully this time it won't take a million years. It should only take like 30 seconds, if that. Let's see what happens. There we go. See, that's what I was expecting. 6 seconds. So the difference between index entries and non-index entries is horrific in 2.13. I just know that. So what does this thing do? Once again, it took an array of names, it added a number to them, and it created up to 100,000 of them. So if I go and click on this little worm thing that moves around for no good reason, and click on star, it's going to return the first 25 things it sees in the graph. Right, and it sees like Sarah 18 and Sarah 8 and Julie 23. If you're looking at this, you may be seeing numbers. You may be seeing like a bunch of IDs floating around. That's okay. Click on one of them. You'll get this little pop-up. Go to the, here's his eye. Hey, I have an idea. Let's create another tab, and let's put an eye there as well. So go to the second eye, and then change the caption to be a username. I don't work in product. I think they for a reason, right? I'm a little too sarcastic about this. Anyway, so the second eye is what we want. Change the username, and then we'll get pretty usernames everywhere, Julie and Sarah and so on. And we click on Sarah, and we get nothing. Right? But they're there, they exist, they have a username property, and there it is. Cool. It's all changing in 2.2. That's what they tell me. It's all going to be so much magically better. All right, so we get a bunch of users, but they're floating in space. And you know what a node in a graph database that is not connected to other node is called?
Loader?
No, useless. So we need to relate these things. So the next step is going to create some relationship between the users. It's going to randomly create a bunch of them. So we're going to plop that in here. And this is going to say 5 million, but only with a random of 10%. So it's going to create about half a million relationships. Go ahead and create these friendship relationship or friends relationship between user 1 and user 2. And we'll hit play. And it will go and it'll take 30 seconds. I hope. Cross my fingers. Demo gods, help me out. I can close this little wiggly, squiggly thing. Go away. And it's like watching paint dry. Dun, dun, dun. We should get better spinners. Because they happen so often. Ah, there we go. 25 seconds to create 500,000 relationships. That's not bad. Remember, it's one transaction, though, so it's kind of heavy to do that much in one transaction. You usually want to split them up. If you do transactions in Neo4J, keep them between 10,000 and 40,000. You're going to have much better life than if you do 500,000 in one shot. It's one big transaction. So now I can go back and I can click on the start thing again. And what it's going to do is going to grab the first 25 nodes, but it's going to notice also that they're related to other things. So it's going to grab their relationships as well. So we have Christine 4 and Amanda 15 over here. And I can drag around and play around with it. And I can see what's happening. If you double click on anyone, it'll try to grab the neighbors, but there's too many neighbors. So don't do that, because I've created thousands and thousands of neighbors for each person. So you just grab a few of them at this point. So we have a graph. It's connected. It's very, very connected. Like, this is like Facebook to the extreme. Every person in here has like 1,000 relationships. And we're going to see it a little bit later. But we have our data. Now I can go back and create my index. Right? I can create my schema. And this will run in the background, hopefully. Super fast, right? And didn't have to do anything. And what's up with that? You know, that's why you always drop your indexes. Database people know. But that also means that I will make a change here to help out future people not have a bad time, or myself. All right. And I should have used pound, and it would have done it automatically, but that's what I get for not following Markdown properly. All right. Enough nonsense. We are here again. We made some users. We connected our users together. We had these relationships happen between them. And now we can get a user and get a proper username. So, Firefox. The first user, let's grab Michelle 11 here. Michelle 11. Hit play. All right. And we have a valid user, right? If you do Michelle 12, it should error out, because that should be like somebody else. But Michelle 11 is valid. We can just hit play to run it and get that. We should have a Michelle 1, I believe, as well. And we should have a Jennifer 0. Okay, so we have users, and they're valid, and they're coming back out, and everything's okay. All right, that's like not very interesting, right? That's not the point of graph databases, to get a user back out. You can do that with a key value pair, with a key value store. So let's go on to the next thing. That is friends. So let's get the friends of users. Now, this is something where graph databases excel at for a very particular reason. In a relational database, when you want to find people's friends, you normally have a friendship table where you have a bunch of foreign keys or primary keys for the user that you care about, and a bunch of keys on the other side for all the foreign keys of the users they're friends with. And this table can get massive. Right? Think about Facebook. You have 1 billion people, an average of 300 friends. That means your friendship table is going to be like 3 trillion records, right? Some big number like that. It's massive. And having to join on those tables as you go from one user table to this massive table back to another user's table is very painful and doesn't scale at all. That's why they have to break up their database into many different pieces. The graph doesn't care. In the graph, what matters here is this. How many actual users are connected to this one node? So if this node represents user 1 and he's got 300 friends, and we want to get all 300 friends, we're going to make 300 traversals. That's going to take us 0 time. That is following 300 pointers in memory Once again, it takes 0 time. There's no joins that need to happen. There's no load this whole user's table into memory, load this whole joins table into memory. All that stuff goes away. It's just grabbing these guys out. So how do we do this one? Scroll down. Get user friends. So get the user and the user's friends. So I'm going to cheat and copy and paste this part up here because I'm going to type that monstrosity in. And this is going to get me the user. And then I'm going to say if the user is not null, then I want to get his friends. So how do we get friends out of the graph database? Well, we have a user. Actually, we do it in a for loop. So we have a user. It's a node, so it has relationships. So we have these relationships. I'm going to call it rel relationship. And they're going to come from the user.get relationships. And you have many options in get relationships. You can just get all the relationships, period. Or you can pass in a direction and a type. So we do care about that stuff. So we're going to say relationship types dot friends and direction dot both. We don't know which side the friendship is coming from. So we're going to get them both. We're going to go into our for loop. And then what we want to do is add to this results array the friend's name. So we can say node friend is going to be equal to the relationship get other node. In other words, we don't know if it's an incoming or outgoing, and we've jumped from a node to a relationship, and we need to get the other node. So it's the other node compared to us. And what we're going to do is take these results, we're going to add a username that is going to be no, not username. Let's get the actual username, which is going to be friend.getProperties and username. And why is it complaining? No, need to cast it into a string. There it goes. Gotta love Java. All right. What is that doing? Once again, we're getting a user from the graph by the username being brought in this path parameter up here. We're saying if it's not a blank user, we found it in the graph, get all the user's relationships that are of type friends in either direction, so both the incoming and the outgoing list from that array picture I showed you. We're going to get the other node, and we're going to get the property of the username of that other node. And we're going to stick this into this list. And we have another unit test called getUserFriends down here. We're going to remove the ignore, and then we're going to say go ahead and run this one. Run tests. Let's see what happens. Hopefully this is right. And it passes. So that means everything is okay. This is more reasonable, right? Get relationships and then a type in a direction. Everyone with me on this one? This one makes sense, right? Give a user, go to the relationship, and then from the relationship, go to the other node, and then from that other node, give me back the property. That's how you traverse a graph, or a graph database in this case. From a node to a relationship back to another node. Now, our relationship could have had properties. We could have had, when did they become friends? How strong their friendship was. Is this your best friend forever? Or is this somebody you barely know? Somebody you met at a meetup? Or love of your life? All those kind of things can go into a relationship property. In this case, we're skipping that. We're going straight to the other node and making that happen. So we can go to our shell here, and we can say maybe clean package. And I'm sure there's another way of doing it, but like I said, I am a Ruby developer. This is as far as I get with Java. And I'm teaching a Java course online. Isn't that crazy? We're going to copy this to the new jar file to our Neo4J. We're going to restart it. Voila. Or almost voila. It'll take a minute or 3. Alright. And then we should have a new endpoint. We should be able to say, given Jennifer here, who are her friends? And hit the magic play button. And then we get this humongous list of people. These are all the usernames that are her friends. So Jennifer has lots and lots of friends because we force her to have 1,000 friends or so. And it just goes on forever. And I think it breaks at some point and says, you know what, you got too much data here. We're going to stop. Download to see the complete response. So there's a button up here called download. and it'll give you the whole list. But now we can get friends with Jennifer, right? And we can get friends with someone else. See, let's try Christy99 something something 4 here. You put her username up here. The magic button, hit play, and she's only got 4 other friends. But Christy44 could have a ton more. Let's see. What do you have? Yeah, a whole bunch as well. Cool. So that works. Now, it doesn't matter how big your database gets. As long as it fits in memory somewhere, then this query will come back incredibly fast because you're just hopping X number of relationships. You know, if she's got 1,000 friends, it's 1,000 relationships. It costs you nothing in the graph to traverse that.
How do we join multiple graphs then? How do we combine? How do we infer relationships between multiple graphs?
Well, actually we can do that next, in a way. The question we're going to ask is, given my friends and their friends, in other words, the subgraph of their friends, who should I be friends with that I'm not currently friends with? You know, because if 100 of your friends are friends with this one person and you are not friends with them, it probably means that you should be, or you may know them, or next time you go to a party, they'll be there. So you should, you know, introduce yourself and become friends. So this is going to be friends of friends. We're going to get the friends of friends. Question in the back?
Yeah, it's a maybe a more generic question, but there are a lot of queries on graphs that I guess you can't treat them as a directed graph. So does Neo4J support undirected graphs or even graphs with higher than pairwise interactions?
Sure, we kind of just did that actually. See this direction at both? It means go both directions.
Okay.
We can also go outgoing, only go in the outgoing direction, or we can do incoming, saying it's only going to support incoming graphs.
But that means the edges are still directed, right?
Yes, but you don't have to treat them as such, though. So remember, in the data storage layer, there has to be a type and it has to be a direction. Okay. But we can just say, we can say this too. We can say get relationships, and it'll just get them all, regardless of type, regardless of direction, regardless of anything. The real magic to graphs, though, is having these multiple relationship types, right? If you look at a lot of the literature in graphs, it's always about a single connection, right? And some of these graph computing engines, they always work about a single connection. The pages are linked. The users are linked. That's not interesting. What's more interesting is how they're linked. What is the magic between how they're linked? Is this person next to you a friend, a coworker? Do they play in the softball league that you do? You know, maybe your kids know each other, and therefore you both go to your kids both go to the same school, or you go to the same church, or you know, you come to the same meetup. How do you know them? You know, how are you connected? That's what's more important. Being able to say the different ways of how we're connected have some more meaning versus just they're connected. And that could be in strength, it could be weight, that could be some other things, or it could, you know, it could be used to expand the algorithms that are out there in more interesting ways. It's kind of getting up there, but being able to create your own graph algorithm is possible now. And traversing these paths in different ways give you different answers, give you different insights into your data. And that's the ultimate idea. If we have time, I'll go into a tirade about graph thinking. Here's the trick. Here's how you start thinking in graphs. Because people always ask, how do you do this? You take an hour of time in your life, sit down, and think about all the things that are currently rolling around in your head. Right? You always have plenty of them. And then you ask the question, how are they connected? Right? How do they connect? How are the things in my head connected? You're going to get stuff back from your childhood. Right? Your favorite sci-fi novels. That thing you read 2 minutes ago on Hacker News. You know, that blog post that you read 3 months ago that stuck with you for whatever reason is still there. How are these things connected? And you try to find some theme or some topic. Right? Like I was trying to figure out, how did Twitch TV get $2.5 billion? Right? Mind blowing, right? I didn't get it, and then I figured it out. I think I did anyway. So, if you guys heard of this game called Destiny that came out, it got a lot of hype. Now I'm a grown ass man. I don't play video games, but I was like, all right, I got to try this one. So I install it. You know, I bought the thing. I am playing it. I played like the first 4 levels, and I'm like, all right, this is kind of interesting. I'm killing things left and right. All right, it's gonna get boring really quick. And then I go on YouTube and I look at some videos of somebody else playing it, right? And the person is talking out loud while they're playing the game, and I'm seeing their fear as the monster comes up on them. You know, I'm seeing their reaction and they're screaming and they're involved. They're saying, "Oh, let's look at what's going on over here." You know, they're telling me what's happening inside their head. Right? I can listen to what's inside their head, and I just did that a minute ago. I was in my own head, listening to myself experience it. Now I'm experiencing it through their eyes or through their head, and that's something you don't get very often. You are disconnected right now. You have only the one voice inside your head, and you can't hear anyone else's voice. But whenever you can get to hear someone else's voice, it's like magic. I think it's like how you can actually connect to someone else, like being able to listen about what's going on in there. You know, there's this idea that eventually we're all going to be connected in some way, right? We'll have this, you know, brain digital interface that we'll be able to talk to. You know, our consciousness will be, you know, online, and that's interesting. But that's not what's cool. What's cool is, what if you can connect to everyone else and have all your digital, you know, brainwaves and signals talk to each other, and instead of having to be disconnected up there, now you're connected to other people, and you're going through the same experiences. Like the Oculus Rift, it's like, why did I get so much money? And then I'm realizing, well, I'm just learning how to play this game called Destiny. Thousands of other people are also playing this game at the same time, and they're going through exactly the same experiences that I'm going through. And some of them are recording those experiences and saying them out loud. Now imagine us all doing that in a more immersive system like a VR system, and we can all learn the same things together or experience the same things together. How crazy would that be? So anyway, that's what you get when you're sleep deprived and driving for 6 hours from Chicago to Minnesota. Let me continue on before you think I'm too crazy. Friends of friends. We're going to build a recommendation engine. In Cypher, this is 6 lines of code. And it's really beautiful. The only problem with it is that it's too slow. So there's a blog post from April 24th called Cypher Translate. This is the Google Translate logo with Cypher in it. And this is how you create a recommendation algorithm in Cypher. Let me see. One too many. There we go. Alright. How many of you guys know Cypher? Anyone? Not yet. Alright. That's why you have those books. So this is Cypher up here. It's saying, find this user, Michelle1. We've been working with her a little bit. Find the people who are her friends. Find the people who are those people's friends. They're friends of friends, basically. And then remove the ones that are already friends with Michelle1. She's the me user up here. So we're going to get rid of them, because why recommend her to be friends with people she already is friends with? And then we're going to return the friends of friends. We're going to count the number of people in between them. That's the friend count of the friends of friends. We're going to order it by that. We're going to take the top 10. All right? That's a very simple, you know, give me the top 10 people I should know type algorithm. Give me the, you know, top 10 people I should connect with based on my current friendships. Now, obviously, it doesn't have to be this light. You can say, well, you know, if I have a weight relationship on the friendship, I can say with the ones that I'm mostly close with, or whatever that may be. Because some of your friends may be family or maybe acquaintances. You don't really care about that. You care about your close friends and so on. There's many other things you can expand on this. But this is 5 lines of code, and you have a recommendation algorithm. The problem with this code is that it takes forever, because it's doing a couple of silly things that we haven't optimized yet. So instead, I'm going to take this lovely 5 lines of code and turn it into 60 lines of Java to get way better performance. So we're just going to go through it, because I think, how are we doing on time, by the way?
7:30.
All right, we're getting there. So this one, I'm going to close. Set up here. Oh my goodness! Hopefully you guys can read all that. So just like before, we're going to get a user. This is going to be our friends of friends path. We're going to get a user. What we want to do is 3 things. We want to find the friends of friends. Then we want to order them. And then we're going to get the top 10. That's what these 2 parts are doing. So how do we get the first friends of friends? Well, we go to this method up here, find friends of friends. That's going to say, if the user is not null, find the first level of friends, and then from that, get the second level of friends. So I'm breaking this up into little pieces. So we have this get friends and get friends friends. So how do we get friends? Well, we kind of already did that, right? We have this method up here that grabbed the friends. So what I can do is, I know I can grab this. I can say, for these friends that are coming in, for the user, rather, that's coming in, I'm going to add to the set called friends the node representing that other friend. So I don't want to get the property, I just want to get the whole node. There we go. So I get with user, I get all the friends, and I add those friends to this friends set that I care about up here. And that's how I get my first level of friends. Easy enough to do. Then I'm going to do is I'm going to pass that set of friends to my next method, get second level of friends. Now I'm going to cheat because I don't want you guys watching me type Java code. I'm just going to copy and paste all this, and then we're going to go through it together. Alright, so what happened here? Our second level of friends, we started with a set of friends already. And for each one of our friends in this set of friends, we are going to get their friends. We're going to get the other node that's not the current friend. And then we do this little mess over here. What is that ugly thing? Well, we want to count them up, right? We want to say the most common people that your friends are friends with, those are the ones we want to show on the top of the list. So we need to get some kind of counter. So I have this little integer, and I'm cheating. I'm basically using an array, a single item array as my counter. So when it doesn't exist, I set it up for 1, otherwise I increment it as I go along. So every time I see a friend of a friend, again, I just increment the counter as I go along too. That's what I'm doing in this crazy for loop over here. Then I remove the current user because the graph doesn't know what you're talking about. The graph doesn't understand that you're looking for friends of friends. All it knows is nodes and relationships, right? Your friends are friends with you, so they can go backwards and find you through this direction both friends relationship. In fact, they will. They all will. So you have to remove yourself from this list afterwards. And then you have to remove all your current friends from that list as well, right? Because in our Cypher query, this part right here is what we're doing. We're saying remove that list of people that I already know from my graph. And then the rest of this mess over here is basically just taking each one and getting their properties and the counts based on this count that we have up here. So I'll skip it because it's pretty obvious what's happening, but we're just returning that back, and then we are ordering it by a reverse comparator, saying go from the top to the bottom as far as the number of items that were in that list. And the reverse comparator is just up here. It just says whatever the value is minus the other one, b minus a, will get you that. So nothing, no magic happening there. And then we can take our unit test of get user friends of friends, remove the ignore, hit the magic play button, or just run this, and it should pass as well. Alright, good. So obviously it passed. So what's happening here? I'm going to show you the unit test for user friends of friends. So if you're a good developer, you know you got to write unit tests. If you write them first, you know, bless you, but I usually write them afterwards. As long as they're written, that's all that counts, right? So this is get user friends of friends. It's setting up, this is JUnit. It's creating a new database impermanently, so it's not creating a real one, it's just in space. And the service is the Neo service that we created up here. We're going to populate our database with some data. This is creating a bunch of users, which basically just have a node with a username key value pair. This is what they look like, how they're connected, and then I create relationships between them. Here's user B connected to, or user A connected to user B to this relationships, friends relationship. And then at the end we do a success, which basically means take this transaction and actually commit it to the database. Without that success, it's not going to happen. Just do it in memory and then trash it out. Remember, you have full ACID in the graph. And then after a populate, we can write our test. We can say, okay, service that get user friends of friends, when we pass in the user A, should give us an array list, and that array list should equal this user A friends of friends. This is just a little test helper that has some pre-made data for us. That way I don't have to keep recreating it over and over again. This is probably not the right way of doing things in Java, but this is what makes sense to me. So that's how I do it. You can see the same test for get user, where we just create the one user and see if the user exists in the graph, and get user friends, which when we create a smaller graph, just A, B, and C, and we see if those three users come back and we request get user friends. There's also another set of functional tests that I haven't talked about yet. So Neo4j is a REST API, and this set of functional tests, they're going to actually run this service, the Neo4j server, and you can connect to it through the REST API and ask questions of it. So we'll be making requests like get service hello world, get service warm up, or for users, get user A and get user B and so on. So we'll actually run it to make sure that you wire everything up correctly. So if you want to see examples of how to create these unit tests and functional tests, they're all in the source code, and it'll make sense to you that way. So I created this friends of friends. I'm going to hope that everything passes when I run it. Obviously, we just run the test, so it should clean package here. We're going to let that finish. Doesn't take too long. We're going to recopy that to our plugins directory. We're going to restart Neo4j, and now we have a new endpoint called friends of friends that we can run. So we're going to give that a second. Let's see, it's okay. I can change this to be friends of friends. Hit the magic run button, and we'll wait a second here, and now we have some data. So what we have is KLE39 came back as a potential friend of friend. Why? Because there was 1,055 other people who are friends with KLE39 that are friends with Chrissy44. And here's Julie13 and a few others, and you see the count goes down the less you go. So I can check this for, what was it, Jennifer 0, I think it was called. I think I missed an N. How do I spell Jennifer? Too many F's. There we go. So yeah, Christy and Michelle and so on, right? And now, so this is a recommendation, right? This is a query that we don't know yet exists. This is what we call a triadic closure in the graph. A triadic closure is just a way to close triangles. So you have a user who's friends with this user is friends with this other person, they should become friends, right? This extra line of the triangle should be created and saying the triangle should be closed, they should become friends. And we do this for not just one other friend, but for all the other friends, and say this is the most likely triangle to be closed. Next time you go to a party, Jennifer, you should talk to Chrissy4 and see if things work out. Now, how fast can we do this? Did I even write that in here? I didn't, but that's okay. We can steal it from here. So, in the blog post, I called this something different. V1 service user Michelle1 / friends of friends. I think that's what it is. How many of you used Apache Bench before? Alright, a few of you guys. It's an old tool. It basically is a way to quickly do a test on performance for your REST endpoints. What we're telling you here is keep a connection alive, use a concurrent request, and run this URL 800 times. Right? And then it's going to go and run it, and we'll get some answer telling us, alright, tested 23 seconds. It did about 34 requests per second. As long as it took for each request, more or less. Were there any errors or there any issues, it tells you about it. It tells you also your min, your median, and your max, right? Which is really the most important thing. You want to keep your max pretty low. Can run this again. Usually, Java JVM takes a little while to warm up. So the first time you run it, it's going to be a little bit slower. The second time it runs, it'll be a little bit faster as things kind of get just in time compiled and all that good stuff. So let's try the second time around. Way faster. And we're doing something like 66 requests per second at this point. Versus the Cypher version takes like 60 seconds to do one, versus 66 per second that we're doing in Java. Right? That's the power you get when you connect to the database directly and ask questions of it directly. There's actually a few different ways to connect the Neo4j directly. There's the API I showed you here. There's also a traversal API, where you get to write traversal descriptions. That is about 25% slower than the one I'm looking at. And there's the internal APIs, which you actually connect to the physical data structures, which you're not supposed to. You only need to use those if you have a critical app and it's just too slow and you got to get that extra 10% juice. Then we go down that route. But it can change between versions, so that's why we don't expose it to the outside world. So it's rarely used. But the Java API is pretty decent, pretty good itself. So this is kind of a quick, compressed introduction to talking to Neo4j directly to the Java API, exposing what you coded up to, through the REST endpoints and adding those to the server so they live as part of Neo4j itself. Like you're extending the database capabilities to be able to do this. Instead of talking to it through Cypher or through the REST API that it comes with it, you're creating your own new one. So you can take this as a service, you can deploy it and say, here's my API that does X, Y, or Z thing, and it's floating around as a service. I can write a client driver in any library, in any language rather, and talk to it and get JSON back and then consume that JSON and do something else with it, or pass it on directly to the user, depending on what that may be. There is a longer, more thorough explanation of how this all works in this video series, Neo4j High Performance. The links should be on, should have been emailed to all of you if you decided you were signed up for it. It's a free video course. I'm only done with the first 9 videos. There's like 23, so I got a long way to go. I'm going to try to get them all done between this week and next week. And I'll take requests afterwards for other things. It's kind of interesting. It's called Archetype, and the idea is kind of like Facebook, but with a little bit more constraints. And that is, you are building a service that can ask, given an email address or the MD5 hash of an email address, what does this person like? Right? And if they like these things, how are they connected to other things? Right? And it's not really meant to be anything real. It's meant for you to be a building block where you build something on top of it. So think about voting. All right? Think about Facebook likes and voting. If you on Facebook tell me you like the show Weeds and you like Breaking Bad and you like the band Fish, I can take a look at you and say you are likely to vote for a pro-legalization of marijuana bill. If you like the church and the Pope and the Family Channel, you are more of a conservative voter. Right? I can know these things without knowing how you're going to vote just based on the things you tell me about yourself. Now, those are 3 things. People have 500 likes, 1,000 likes, and so on. But I can figure these things out about you, and I can connect, the band Fish to drugs, and drugs to this bill that I'm looking for people to vote yes or no for, and therefore contact you and try to get you out to the polls because I know you'll vote in my direction, or I think you'll vote in my direction. That general idea. So it's about inferring relationships between the things we know about them. If you ever have seen my Neo Graph Search application, this is my old Facebook clone, where I can actually go to Graph Search and type things like friends who like cheese, and then it'll actually run that query in English for me. So this is like people who like cheese and live in Madison. So you may show up on here, I don't know. Let's go with Meng here. She lives in Madison and she likes 934 things, right? So tell me about Meng. Well, zoom in a little bit. She likes Skittles and The Onion and Will Smith and s'mores and duct tape and Megan Fox and I don't even know what that is about punching a kid in the face. But she likes all these things. All right. So I know about her. I understand her digital identity based on these things. And if I can connect these things to other things, then I can say, if you like this, you may like something else. And if you like that, you may want to buy my product, which may be X, Y, or Z. And the product could be like a real thing, like you're selling if you like Game of Thrones and you like swords and you like Irish castles, maybe you'd like a vacation to Ireland to go see some actual castles. Or maybe not. But at least I can make that connection and try something out. That's 934 likes. Let's find someone else. Dylan Casada here, 378 likes. What about this guy? He likes Eazy-E, so he likes old school rap, and Will Smith, and Strawberries, and Lex. I don't know what that is about. Something about Justin Bieber. He hates Justin Bieber probably, and a few other things on here. But it's kind of ugly and it's kind of weird, like weird, really strange stuff that doesn't make a lot of sense. So instead of doing that, I hooked mine up to Wikipedia. Because Wikipedia, it's kind of curated. We know what the thing is about. It's a specific topic. If you go to Wikipedia and you say, Wikipedia, I know this user loves Nutella. What is that thing? Right? This is like the nectar of the gods right here. It's hazelnut cream that you put on anything. It tastes good. You pick up a cigarette butt off the street, you put Nutella in it. It tastes good. That's how good it is.
Rubber shoes.
Yeah, pretty much. Whatever you want. So the series will talk about how to build something like that, and then what can you do with it afterwards, which is really the trick to Neo4j. Right? This is going to be very simple, very straightforward, but the more interesting things that you can go beyond that is what counts. Things like how to connect people who could be your potential mate based on the things you both like and hate about each other. So if you were here before, you might have seen this. Hold on. Neo loves. Let's see if he finds it. So how to find the love of your life with Neo4J. This is Marilyn with Groucho Marx. You never realize how pretty the woman is until she's standing next to this dude. But it's a cipher query. Oh, good lord, 16 lines of cipher query. Now, I'll tell you, one of our customers, they sold to eBay. The core of their business was 7 lines of cipher. Right? And they got a few $1 million for that. So, good for them. But it was about how to get the stuff that you buy on eBay now delivered to you within the same day. And the fastest time, I think, was like 17 minutes. Where their SQL queries were taking longer than that. Where Cipher can do it in a few milliseconds. How to get your stuff from one place to the next. But anyway, here's a cipher query that shows you how love works. You say, okay, what do you want in your potential mate? And so I go, okay, I want tall, blonde, beautiful supermodel. And I ask her, what do you want in a mate? And she says, I want fat, bold, nose Neo4J. So we're a perfect match. And the way we find each other is I start with me, and I say, what city do I live in? And what city does this person live in as well? I want to check to make sure that we have the same orientation. So if we have the same orientation, then either our genders are different if I'm straight, or our genders are the same if I'm gay. Obviously, there's a whole gamut of other genders and all that, but it's going to get too complicated for a blog post, so I just kept it simple. And then I ask these 2 questions. What do I want that this person has? And what do they have? Or what do I have that this other person wants? I'm trying to match on both sides. Because a lot of dating sites ask you, tell me about your potential mate. And they have a canned list of like 40 things or whatever it is. I don't know. I've been dating the same woman for 10 years. I don't even know how dating sites work. But, you know, there's a few things on there. Right? But what if you want to get more specific? This little thing here tells you anything. Any concept, any node in between them. So it could be, you know, I hate cats or I hate Justin Bieber. I only want to date people who also hate Justin Bieber. Or I want to, you know, find people who are not like me because I am the guy who likes, you know, death metal. And there's like 2 girls in the world that like death metal, so that's just not going to work. And they'll both live in Sweden. So I got to find someone that maybe likes country music, but I'm acceptable, you know, I'm accepting of that.
Hey,
so,
so, like, remember how you were showing your friend and there was some weird post about Justin Bieber?
Sure.
So let's say your thing said, like, I hate Justin Bieber, and her thing said, I like Justin Bieber. And it would match on Justin Bieber even though those sentiments are totally opposite.
No, because the sentiments are actually a node by itself. So it'd just be the whole concept of one thing or the other. So the like would be the whole ideal. So if I go back to this and I click on like Procrastinators Unite Tomorrow, all these people clicked on this one specific saying.
Okay.
So then that itself is a concept,
Okay.
Which is really strange. Now, here's something else I got to tell you. I don't know any of these people. Keep your hands off my Doritos. I posted this online 2 years ago, and I said, I need some data. Can anyone just, you know, hook up and give me the data? Well, what happens, right? Doesn't matter how safe or how smart you are about your privacy settings and all that. Your friends are complete idiots, and they will give your data away. So I have like a few million people's profiles, and in the 2 years this thing has been up, I've gotten 3 requests to take the information down. People just don't care. They've given up on privacy, right? And they're willing to tell you anything and everything about their life. Let's look at Jamie Carter over here. 560 likes. I know what she looks like, I know where she lives, I know who her friends are, and I know everything about her. What does she like? Coca-Cola, okay, and Friends, and Gossip Girl, and Doritos, and Snickers, and ice cream, and Chick-fil-A. You know, and she hates people who don't text back. Who doesn't? You know, and you're like waiting, and it just never happens, you know, days later. Anyway, so you can know all these things about her. You can make a profile of her. It's not just like, oh, this person is so-and-so age, and she lives in this zip code, and, you know, she subscribes to bridal magazines. Forget that. We're talking about the ultimate in personalization. Every little detail about her life can be known. And not just at the first level. You know, if she likes Fall Out Boy, maybe she likes trans music, or maybe she likes, you know, industrial hip-hop, or whatever that may be. She likes Taylor Swift. That doesn't tell me much. So many people like Taylor Swift, right? But the fact that she likes something else, like Buddy the Elf, or that, you know, helps me understand her better. You know, the less things that are connected to these things, the more I know about them. Right? If you like that indie band that no one's ever heard of, and some other person also likes that indie band no one's ever heard of, that tells me a lot more about your musical connection, versus if you both like Justin Bieber or Taylor Swift or some, mega star like that. So that's what's kind of interesting. It's sometimes not the most connected thing, but the least connected thing that tells you more about what's going on in the graph. And be able to study that and relate them all together and say, well, I know 500 things about you. I can whittle that down to 10 things, and from those 10 things I can dictate whether you're likely to vote for this candidate or agree with this bill or be likely to buy a product or click on this ad or whatever it is you might do. Right? It's your digital DNA we're talking about. And it's out there. You don't need $1,000 to be able to extract it out. You can just ask people to give it to you. And they are willing and free to do so, and they do. I mean, there's proof of that, right? It's all over the place. That's the idea. It's crazy, people are saying. It's almost like tweeting. They're just saying stuff, but people are also agreeing with it. Jonah sees in color. I don't know who that is. Are you stupid? I like you. She likes stupid people. What was that? Graph search. Oh. But if you haven't seen this project, it's also on GitHub. It took 3 days to build. Right? I was on a high, and I was like, I can do this. So forget friends, go with people who like Vikings. Let's just try that. And I get all these people. This guy looks interesting. He lives in Cuba. He's got 857 likes. And if I search for Vikings, he likes Vikings. Look at that.
This is Facebook public API or...
Yeah, this was Facebook public API. So they cut me off. So I'm actually running queries off Neo4j. So if I go to here, Facebook, I'll show you. So I got a cease and desist letter from them back in the day. And it said, your app is replicating our core Facebook functionality. Do not do this anymore. So I cannot get any more new data, but I have already 1 million people's profiles, more than 1 million, a few million people's likes and friends and all that. So I'm actually querying off of my own Neo4j server to get that information. And you type your English here, it translates it into a Cypher query. Cypher query runs, gets back the answer, and then it visualizes their picture and what's going on here.
So you have to subscribe to your app?
No, it's cut off now. You can't do it now, but you can. There is a link on the right. No, that's not it. All the way at the bottom, code. So there's the code. You can clone it, sign up for an API, and basically start sucking in data. There's a job in the background that runs that sucks in data and saves it all to Neo4j until they cut you off eventually, right? But they didn't block me or anything. They just cut me off, and that was it. It wasn't like, it was a little spank. It wasn't bad at all. Violating people's privacy galore, but they don't seem to care, or their friends didn't seem to care. So they should be mad at their friends, not mad at me. That's what I think. I'm not hacking anything. They gave me their data. So they got Matthews here. Some of them don't have so much. 25 likes. He keeps his stuff closer, but we can do weird things like search for people who like bunnies and MMA. That's one of my favorites. Because it just doesn't make any sense. Right? So he got Cesare, he's got Pitbull, and he's got 65 likes. And he likes MMA, and he likes bunnies. He likes snow bunnies. So it's not quite bunnies, but close enough. Similar idea. You guys are probably all douches. 397 likes. Buddy.com. Jake Cutler. Whatever. Megan Fox, Metallica. You find out really strange combinations about people. And you can also ask those questions. If someone likes this, are they also likely to like something else? You can get those correlations, and you can say, well, people who like Metallica maybe also like Megadeth, but they definitely do not usually like Taylor Swift, or that kind of thing. Well, what kind of information can you get out of that? And somebody did some studies on this and found people, who were like smart like this stuff and who were dumb like other stuff. I don't know how valid or legit that is, but you can try it. You can also visualize the graph. People always love visualizing stuff. So here's a visualization of like 50 random friends of mine. Some of these are fraternity brothers, some of them are family members, so they connect differently. There's a whole set of blog posts on visualization and graphs. If you want to sell Neo4j to your company and say, or sell graph databases to your company, build a project, add a little visualization, and your upper management people, the ones that have no air up there, they'll buy into it. They love it.
This is D3.
This is D3. There is hundreds of different libraries you can use, but D3 has become almost like the standard, I guess you can say. But there's a few others that are more specific to graphs. There's VivaGraph, there's, I'm forgetting the names, but just go to the blog, go under visualization, and there is a bunch of them. Where's it at? Visualization. Right. Right, here's one I did recently called Twilio. All right, how many of you guys know what an IVR is? Interactive voice response, right? You get on the phone, you call them up, and they say, all right, press 1 for this, press 2 for that. You know, press 1 for Spanish usually, or press 2 for English, and you go on from there, and it tells you you're looking for, you know, for maintenance or for leasing or for sales, whatever it is. In this case, I built one for a property management company, a virtual property management company. So if you want a maintenance request, press 2. If you want to talk about billing, press 1. Something else, press 3. And then that goes on to the next one, and it tells you about it. And as you're clicking around, you're basically following a path. And if you can follow a path, then you know you're talking about a graph. So I connected them up to Neo4J, and so every time I click on something, I'm going to create a new event and follow the user as they traverse through this path. And then I end up with something that looks like this, where I have the route, where they all come in from, you know, how many ask for billing, how many ask for maintenance, and then where do they go from there. Obviously, this is a very small, I'm just only going 2-3 hops away, but you could go on forever and ever and see, you know, how far into the IVR do they go, when do they give up and say, give me a representative, I'm sick and tired of this. And this is great for an IVR, but where the idea comes from is you can take this and you can also use it for things that are not IVRs. Like Nick did one for web histories. So user comes into the website, they click on this link, they go here, they click on that link, they go there. How are people traversing your website? Which ones are going through a path that leads them to a conversion? Whether that is a subscription, whether they buy something, or they sign up for your newsletter, whatever that could be. And which ones go in a route that end up with nothing? People who eventually leave without buying something or signing up for something. And then being able to figure out, you know, which ones are the good paths, which ones are the bad paths as your site changes. And then sometimes being able to hijack them and say, okay, they're following on this path, they're going down a way that they're likely not going to convert. I'm going to change the content dynamically. Ask them JavaScript to change it dynamically. Or even worse, I'm going to highlight, click jack them, I guess that's the term. But they click on something, but my JavaScript says, you're not going there. I'm going to send you somewhere else instead to try to force them to buy something. Because if I can just get that extra 1%, you know, a conversion rate, that's millions of dollars for somebody. So it's all about making those kind of things happen. And we have some of the big vendors are all doing this kind of path analysis and click analysis to see where things are going. What's another one that's a path? Your job history. Right? We have some of the big vendors, big software companies come to us and say, look, we have 400,000 employees, right? And we've been around for 100 years. So what is the fastest way for a level 6 IT specialist to get to a level 9 IT specialist? Or for a level 6 person to get to level 9, period. Right? And you have different tracks. You have the management track, you have the technical tenure track. You know, this person could become, you know, an IBM fellow, or they could become, you know, a mid-level manager or an upper-level manager, or maybe even get to an executive level. How do they get there? What's the fastest way to get there? What skills do they need to get there? What skills do they learn along the way to get there based on, you know, what previous people did? You can ask things like, if I had this degree, how would that change my career path? If I had these skills, how would that change my career path? If I decided to take an assignment overseas where there's less talent, how would that change my assignment? Or a different city where there's less talent, how would that change my future path? You know, a small company, not a big deal, but in one of these larger places, you know, it makes a lot more sense to ask those kind of questions. So it's not about what's in the graph and what's connected and what the current path is. Also think about is what's not there, what's not connected, what could be connected. Because the graph will tell you both, what's connected and what's not. Right, this, going back to, not Twilio, the query I had when we were talking about love. I think I can do this. No, forget love. Let's go with something else. Matches with a new hotness. Let me show you this one. This is my idea of a joke. Here's a match on fire. That's matches the new hotness. And here's the idea. You have this user. He lives in a place. He knows two things. He knows C#, he knows his database. And we have these job openings that require you to be in that place to know this skill and to know this database as well. So how do we build this recommendation algorithm to match those people up together? One too many times. Here's a software query. We start with the user, and we say, okay, what skills does this user have? What city does this user live in? What jobs are also in that city, and what are the requirements of those jobs. That's the traversal we're doing in our graph. We want to make sure that I have at least one way to hop between the user and a skill or requirement that the job has. So these skill nodes and these requirement nodes are really the same nodes along the path. I'm going to make sure that I have at least one. And then what this thing does is get all of the matching skills, all the times that I can connect to a job by something that I have, find all the requirements of that job, and then do this little weird filter at the bottom that says, take all the things the job requires, take out the ones that I already know, and tell me what's missing. What do I not have in the graph? Because I want to get to an interface that looks like this. Here's user Daniel. He lives in Dallas. He's got these skills. He's 100% match for the first job. Like, he's missing nothing. So this person should apply to that job and will likely get it. Or depending on whoever else is also 100% match. The next job says, oh, you're missing CSS. Well, nobody puts CSS on their resume, right? So he just clicks the plus button, and automatically he's 100% match for that job as well. Then it's the third job. It says, oh, you need to know Java. It's like, uh-oh. Well, you know what? Screw it. I'm going to lie, hit the plus button, and now he pretends to know Java. He'll learn it over the weekend. You know, hopefully he's smart, figure it out. Try to bullshit his way through that job and get that. So you're never going to prevent the lying problem, but it's a way to do a partial subgraph match and return what's missing in the subgraph. A one-to-many. The one is Daniel and his subgraph of the things he knows. The many is all the jobs that are out there that could be potential matches for him. You're matching one subgraph against many and also returning what's missing between them. Question?
Yeah, so how long does it take to run that? Because we just went through writing 60 lines of Java code to get friends of friends. And then you show us this. I'm just kind of curious, like, what's the performance of this? Or
the performance of this is pretty bad. There's better ways to write the cipher, but this is the way I wrote it so that it fit in a blog post and made sense.
Okay.
I'll tell you, it's not that bad. Okay, I went to this company called Elementum in California, and they do supply chain management. The idea is, if there's a fire, or there's a flood, or there's an earthquake, or there's a military coup, and it affects your suppliers, or your manufacturing facility, or whatever it is, how does that affect the product that ends up in Walmart shelves? Right? All of the different links along the way, all the different parts that get added together to make more parts, that get added together to make more parts. It's a really crazy, complicated world with raw materials on one side and finished products on the other. All right. So what happens if stuff gets affected? How does that affect the path? What are the things that have no replacement? In other words, if this facility goes down for whatever reason, I have no way to make that product, or I have a huge delay because my capacity is reduced and all that. That query was 500 lines of Java code. It started at 6 p.m., was done by 6 a.m. the next morning, so it wasn't that bad, 12 hours. And then you had this, it was doing it like in 40 milliseconds, something crazy like that. And we were doing hundreds and hundreds of requests per second, it was flying fast. It's not that bad. You just have to do 1 or 2 or 3, and you get used to it, and then you kind of start thinking in the graph way. There's lots of examples that kind of look like that already in my GitHub repo as well.
So you're saying that you're showing the cipher just for the blog post,
but
blog. Behind the scenes you're probably writing Java code.
Yeah, nobody is going to, like, if I wrote,
right.
I mean, you're going to read 500 lines of Java code? You go crazy, right? But it's really not that bad. It just takes a little bit of practice, and a couple of times you do it, you get through it. That's why I'm trying to teach the Java way of doing things in the video class, in the, where did I go? In the Vimeo class. Just to get people used to writing the Java way, just for their own purposes. Now, 2 years from now, you may go back and think of this, Max was an idiot. Cipher stuff is so fast, I don't have to write this Java code. And I hope that's the truth. I hope we get to that point where this is interpreted in such a way that it runs very, very fast and I don't have to ever write a line of Java. But until we get there, and I'm trying to give you something and tools that you can use today, not 2 years from now, because otherwise I'm just selling you air. And I worked at IBM. You don't want to do that. They do too much of that already. Well, they used to back in the day. I mean, the graphs are interesting. I fell in love with the tech 4 years ago. I was a database guy forever. I was doing SQL Server stored procedures. And I joked that 4 years ago, I would spend my time writing or optimizing stored procedures that were 500 lines long, written in SQL. Now I spend my time optimizing stored procedures that are 500 lines long, written in Java, to do exactly the same shit. So my job hasn't really changed, even though the technology is completely different. It's still the same skill set. you still have to keep everything in your head as you go along. But it is interesting. It is different than you're used to. You're used to relational or object. It gets weirder. It is addictive, I think. There's people out there who have been at this for longer than I have, and they're all completely insane. They really, really love this stuff. We hope that people become part of the community. It's not going to be the next Oracle. We don't make millions of dollars every time we make a sale. We barely scrape by, but so does everybody. So it's not that big of a deal. The job does pay okay. So if you, since there's so few people who actually know this stuff, if you're going to become a consultant, building Neo4j projects for others, that pay rate is pretty good. So if you're a junior person, I'll give you this advice. I don't see any juniors here, but become the expert at one thing. I was a generalist for a long time, so I can build a server, I can secure it, I can build a web app, I can do Photoshop and write CSS and write JavaScript. I can do it all, but it doesn't pay, right? But if you know one thing really, really well, you become the expert at one thing, whatever that may be, then you're going to have an easier career path, easier time making money. And as long as you pick something you love, and hopefully it sticks around, because Neo4j could be dead in a few years, who knows? But I got to tell you, what's kind of crazy is this is old hat. This is one of the first databases that were out there, Codicil. Look at that year. That was like the first graph database, 1959, before SQL, before relational. Like back in the golden age of computer science, when people were just starting to figure this out, man, they had crazy ideas, and they try to build anything and everything, right? And we're just catching up to them because the hardware is good enough to be able to take, what they dreamt of and actually make use of it for something that makes sense, right? Like in those days, you'd get, 10 traversals per second in that one core that you had. Now we're doing millions of them. So those old ideas are kind of getting rehashed. Object databases are also pretty old, probably older than NoSQL as well. They're all just coming back. So take a look at what your ancestors did, or our developer ancestors did, right? They were a little bit insane back in those days, but they got stuff done. So take a look at that. We had the dark ages of SQL for 20-something years, but now there's no SQL movement that started now 7 or 8 years ago. It's really brought all these crazy ideas back, and hopefully they keep going. So hopefully we get more crazier stuff. I've seen some new databases out there that are matrix databases. So the idea is kind of like a giant Excel database in the sky. A lot of people are doing stuff, with tick databases and time series databases. So whatever your app has, so however you data need to talk to, and someone's trying to do things better than the tools you currently have. And the in-memory stuff is pretty interesting. I mean, the fact that network is faster than disk now is I think it's a game changer for a lot of people. So just keep that in mind. Forget disk as storage. Think about just redundancy as storage instead, and see how that leads. Any questions at this point?
I have a quick question.
Sure.
Can you talk briefly about how to scale a Neo4j store into 2 or more machines?
Scaling a graph database is an NP hard problem. So the answer is really you can't do it. You have to only take your best try at it. This is how I scale databases. I get a bigger box. So memory is cheap, right? That was the price from 2012. You can get twice the RAM for the same price nowadays. So we always see people just buy more RAM. This is WebNX. This is a web hosting talk. So if you come away with anything in this talk, it's this thing. You can get really, really cheap servers from web hosting talk. This is a forum that's been around since like the 1980s or something like that, before the first bubble crashed. And in here, you can, all the major vendors give out crazy deals, like end of month specials and so on. So, people you know and love are giving away this stuff for half price than you would pay normally. But I like this vendor out of LA. They usually have crazy, crazy deals for really cheap. I've been using them for years. But I have no relation. I get no money out of it. I'm just telling you. So what do we got here? Give me something decent. That's only 32 gigs. Something bigger. Here's 64 gigs for $400. That's not bad. You usually can do better than that, though, if you ask. but they have terabyte servers. They have half a terabyte servers. You can lease them now for about $2,500 a month if you wanted a terabyte, really. There's a blog post on that as well. So go bigger. Now, a lot of folks work in Neo4j distributed by having multiple servers, and they have different parts of the graph in memory. So Glassdoor is one of our customers. They're running 3 boxes, 384 gigs of RAM each. And the way their system works is they're recommending jobs to people based on their friends as referrals. Well, when the U.S. goes to bed, Asia Pacific wakes up. So the nodes from Asia get loaded up into the graph, loads from India get loaded up into the graph, loads from Europe get loaded into the graph, and then as the time changes, they finally load up the U.S. nodes as well. So they don't have to have everything in memory, they just have to have enough in memory for the concurrent users. And thankfully, we spin around this big ball of destructive energy in the middle of our little solar system, so we get time zones when people go to bed. So that helps. If you have to be 24/7 all the time, then you can shard in memory as well. So we have another customer. They have all of your high school social networks. So they have your yearbook. They've scanned it in. They've taken your picture and your friends' pictures and all that, and they've created a graph out of it. And they sell you memorabilia, which sounds really strange to you, but when you're 50 years old or 60 or whatever, and you're looking at all the high school pictures, you're like, that's kind of cool. And let me order that yearbook, or let me order that class ring, or let me get nostalgic about the high school trophy I had back in those days. And they make their money doing that kind of thing. So looking at old pictures and connecting you based on what year you graduated. So the people who graduated in 1950, you go to one server. 1960, go to a different server, because you're only going to be connecting to people plus or minus 4 years from you. People who went to the same high school as you while you were there, obviously. So there's always ways to kind of shard your data, if you can, either by time zone, geography, or things more natural like when you went to high school together. Distributed database is something we're working on. Everyone is. If you guys have seen Titan, they punted and used Cassandra for their backend. OrientDB punted as well and is using Hazelcast for theirs. We're building our own, and it's taking forever. The reality is that our customers don't need it. The great majority of our customers have 1 billion nodes and like 12 billion relationships, and that's really all they need. So you can fit that on a server, right? You don't need to have a distributed version of that when you can fit it all in one. So it's kind of pointless. I'd rather have 3 big boxes to manage than having 1,000 little ones to manage. Because when you have 1,000, something's always going wrong. When you have 3, hope to stay up.
So 1 billion with 32 gigs of RAM?
Yeah, should be fine. I mean, you take 14 bytes times the number of nodes you have, 34 bytes times the number of relationships, and then you add the properties. So you have lots of properties, you may need more. If you have less properties, then you may need less. A lot of people also don't use Neo4j by itself. They hook up Neo4j to their document store. So you'll pass all the massive data to Mongo or CouchDB or one of those, and then you'll store just the relationships in Neo4j. And you'll ask Neo4j, given this one node ID, go find some information about them. You'll get back a bunch of IDs. Those IDs map into Mongo IDs, and then you hydrate the object. So you say, okay, here's a bunch of IDs. Now create the full object for them, and then pass it on to the user. And we see that so much, we call it the Neo4j Mongo combo, because it's everywhere. Document databases suck at relationships. They're absolutely horrible at relationships. So tie them up to something like a graph to make your life easier. What else? Whenever you think about a domain or a space you have, if you have big join tables, that's probably a good sign you should think about graphs. If you have 500-line stored procedures, that's probably a good time to think about graphs. There's a ton of examples of domains and things to use it for. So if you go to the blog, there's 61 things on there. I pasted into the Meetup group a list of other ones from other people who are also blogging and looking at their experiences. In HR, in security, in biology, your pathways through your drug interactions, your genes, all that stuff is networks. We had a company who spent about a year building a recommendation system for cancer treatment. The idea is you have chemotherapy, you have many different types of chemotherapy. Which ones do you give someone based on their DNA, and what's likely to work or not likely to work? And obviously they don't let the machine choose by itself. It's the machine plus a doctor making a combined decision. We're not there yet. We're going to take our fate into the hands of a software program that may have bugs, but that's the idea. There's many other use cases, in everywhere. And the one use case that's universal is people, right? Your social graph your company's social graph is important. You know, the people you worked with in the past, or they've worked with in the past, you know, are people you want to bring onto your team or hire because you know how good they are, or you want to avoid because you know they suck and they want to work with that manager again because he's a micromanager, blah blah blah. You know, those kind of things. You can leverage that, and you can find that use case in all of your companies, but many others as well. We just start thinking about how are these things connected, what can I gain from information, you know, and what if scenarios. What if these things were connected? How would that change things? And see what comes out of it. But no, I mean, we are hoping next year is a year, and I've been saying that for 4 years. So who knows? You know, the first time I got introduced to Neo was at this. I was watching this video by a guy who went to CDDB, and he was talking about modeling his comic book collection. And he was like, "Well, I tried modeling my comic collection in relational world, but it sucked. Then I tried document databases, and it sucked as well because comic books are so crazy. You know, people live and they get reborn. Enemies become friends. People become their own mothers. I mean, crazy things happen in comic books that shouldn't happen, right?" So that was his idea back in the day. And then Marvel was like, you know what? That's a good idea. So they actually built a graph of all of their comic books. Where is the... There's a video in there somewhere. Maybe the full article has a video. But, yeah. They took their whole universe and mapped it all out in the graph, and they can ask questions about it and follow different paths because it all makes sense in a graph. You know, the things that happen to people can be anything, and the graph lets you connect anything to anything else. There's like a 45-minute video on how they went through the data model of how that looks like. It's kind of a quasi-hypergraph what they had to use to make it all work. And Marvel is a company who is now worth billions and billions of dollars because they keep making movies that people go see, even though some are crappier than others. You know, where's DC? You know, Ben Affleck making Batman. Did anyone want to watch Gotham the other day? Was that cheesy as hell or what? Did anyone like it? Okay, it wasn't bad, but it felt like a kid's show. I don't know, except all the people dying. Really strange. Anyway, who knows what's going to happen? But there's graphs everywhere, and that's one of our marketing taglines. Try to find the graph in your domain. If you can build a graph for your domain, you can make lots of money, or you can at least have something of value. There's a few folks out there who are trying to build or to be the graph of sports. They want to be able to say, if you travel to a city, what is a sports bar that's local to your college team, for example? So you can go there and have a beer, right? That makes sense. The graph of supply chains was Elementum that I talked about. You know, the graph of DNA, the graph of medicine, the graph of, I don't know, think of anything. Somebody was, you know, we're looking at cars and automated cars and cars having, you know, wireless connections in them. You're going to have a network of traffic. I mean, you have ways now, but you're still kind of isolated. Wouldn't it be interesting for all the ways people to kind of just talk to each other? What kind of opportunities does that open up? Being able to see, you know, what's that person seeing in front of them, you know, 3 miles on the road? How bad is that car accident? This kind of, where is that cop that I didn't see? Who knows? But our world is getting more and more connected, and you should learn about connections and graphs and how that works. And you might find a crazy use case for it or not. You know, keep it in your back pocket. It's just a tool that you can pick out and take back out whenever you come into a problem that has it. You know, if you're doing graph stuff already in relational, get it out of there, put it in the right place, and who knows what could happen. Any other questions? Yes, in the back.
Another oddball question. So, what would you say about using maybe just some high-level Python in a graph library?
Sure. So, if you go to neo4j.org, you go to develop. Usually there's a bunch of articles here. There's language drivers as well. And there's Py2 Neo, I believe. So there's this one, and there's Neo4j Django, and Bulbs, and a few others.
I guess my question was more, like, do you do this for the REST API services? Or, I mean...
What I do is this. I tell people, when you're just getting started, find your favorite driver. You know it. You understand the language. That's good. You don't have to learn Java, right? Write your queries in Cypher. Learn Cypher, because it's really a powerful language, and it will expand your mind as far as what you can do with it. And then when you get to the queries that are taking too long, that's when you say, okay, I'm going to hold my nose and write this in Java and add that as an endpoint and just connect through the endpoint directly and get back a JSON response and go from there. A lot of our customers don't do 100% Java. In fact, most of them go the other way. They have 90% Cypher queries and 10% Java. And the 10% is like the hardcore recommendation algorithms. The 90% is things like, give me the user's friends. That's going to be quick. It's the crazier stuff that takes a while. Before production, it doesn't really matter how slow it goes. It's only when you get to the performance testing stage and you go, okay, this is a little bit lower than I want it to be. My SLA is X, and this is X plus Y. So let's bring it down. How do we do that? Let's rewrite it into an extension. There's all kinds of tricks you can do once you go Java, though. You can cache the crap out of everything. So there's a blog post on caching all the things. There's a blog post on, if you want to go all the way, you guys remember the Spaceballs? Everyone loves Spaceballs. Oh wow, that picture's bad for some reason. Reload. There you go. So Undertow is a high-speed Java web server that usually gets good marks in the web framework benchmarks. So if you go to like round 9 or whatever it is, and you look for Undertow, it usually gets pretty high marks versus something like, I don't know, Ruby stuff. That's pretty horrible. So I decided to use that. You can connect it up directly to Neo4J using this really like path handlers. Let me zoom in a little bit. So here's Hello World. Here's this cross-reference thing. I don't know. It's Java. It's really Java though, but it's pretty fast. It's like about 5 times faster than the web server you get out of Neo4j Direct. But you have to now manage the whole thing yourself, which is kind of painful. But if you're a Java shop, that makes sense. And then if you wanted to go crazier and say, well, I don't need HTTP, I can use WebSockets. Then I have another post on how to turn that into WebSockets as well. And the magic number is 28,000. So I start out at 1,000 requests per second using regular Neo4j. I jump up to about 6.5 times, or I think it was 8,000 requests per second using Undertow. And when I switched to WebSockets, I went up to 28,000 requests per second. The reason why this moved up so much is because the actual traversals I was doing were very, very small. We're looking at credit card fraud. Given a credit card, an email address, an IP address, username, whatever, how many times has this been used with other things before? So if a credit card has been used by 50 email addresses, it's probably a bad sign. If an IP address has been used by 10,000 other people, probably a bad sign. All these kind of things that feed into a larger fraud detection system. And the customer came in and said, we have this cluster of servers, they do about 1,000 requests per second altogether. I was able to get them 1,200 requests per second on a laptop the first time around, and the third time it was 28,000 requests. Because it was all about the transfer. The traversals themselves were just following pointers, doesn't take very much. It didn't cost very much at all. It was really all about the transfer. So if you have queries like that and you need speed, you get 2 options. 1, get a cluster of Neo4j instances, or 2, go a little bit more hardcore and do it the Java way. I will be doing a little bit of this in my video series. At the end, I have it a little time saved up for if you needed to go faster, how do you do it? And then I'll show you what that looks like as well. But if you want to know more about graphs and my exploration of them, go to maxdemarzi.com, go all the way to the bottom, go to January 2012, and read your way up. By the time you get to now, you'll know everything that I know. I have a really horrible memory, so I keep everything in the blogs. I also do a lot of GitHub, so it's all there. And you can see my repos just go on forever. I mean, like forever, 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 forever. It's all like 4 years of open source example code of how to do Neo4j stuff. So you can learn anything and everything there. There's my ugly head, but it was nice. It's mostly green, thankfully. A lot of the stuff is great because I'm doing private work for clients, but a lot of it is is open source and you can play with it and do something with it. And if you do, please contribute, give it back. Write about your experiences, write about the blog, complain if you don't like something. Especially like what the hell is this? Why couldn't you give me a nicer, cleaner API than that? I don't know, but that's Java people for you. I'm a Ruby guy, so every time something smells bad, I just have to point it out. And Ruby was meant for like developer happiness. If you can't do it in 5 lines of Ruby, it's too hard, right? Do look at my post on the Facebook graph stuff though. it's pretty crazy what you can do in just a weekend if you're insane and have no fear. Because you never know if you can do something or not until you actually try it. So you look at the commits. This was like Friday, Saturday, and Sunday. I was basically done after that. It doesn't take much to build something like this. Especially if you don't know anything, you just learn it as you go along. And a lot of it is fake and punted and things like that, but it still works. It's all that matters, right? That it works. And you can learn from my example. Somebody actually took this and built it for their own app. They use it for querying. It's a security or it's a network infrastructure management application. The ask questions like which server is affected by zero-day vulnerability, which important servers are down, and the user just types in English, just text bar, that translates into Cyber query. It runs and actually gives them the answer without them having to try to figure out a report or look at this, look at that, just ask whatever questions they want. Kind of like ad hoc and to the business analyst level. It doesn't have to be, like I said, people's likes. It could be medicine, it could be doctors prescribing stuff, it could be your genome, it could be whatever you want it to be. Go crazy with that. Plenty of examples. And if you have any ideas for a blog post, let me know. I'll draw something up and put it together if you don't mind sharing it with the world. All right. Thank you guys for coming out. I appreciate that you all came. I was surprised to see how many people signed up. You guys have a great meetup. It's nice to see a health meetup with 50 people every single month. I try to do one in Chicago, and I slug off during the winter because nobody comes in the snow. So I'm sure it must be bad in a few months. So it's great to see the community people coming out here. Thank you for having me.